Hi friends, in this video I would like to share fundamental sampling distribution. Fundamental sampling distribution. First of all, we have to learn some basic terminology about fundamental sampling distribution, which are population, sample, parameter, statistic, and sampling. First of all, we have to learn what is population. Population looks like a universal set. We know that a universal set is the possible set of all subsets. In the same way, we can define population is also the set of all possible observations of a statistical data. The set or collection of all possible observations of a statistical data. Statistical data. These observations may be either numerals or alphabetics. These observations may be either numerals or alphabetics. For example, the number of students in a college. In the same way, we can define the number of nationalized banks in India. Now, I would like to explain about sample. Any subset of population is said to be a sample. Any subset of The population is called a sample. That is, all subsets, each subset is called as a sample. Out of all subsets, each subset is known as a sample. For example, the number of students of CSE branch in a college. The number of nationalized banks in Telangana. Banks in Telangana. Now, I would like to explain population size and sample size. Population size. Can be denoted with capital N. Population size is nothing but the number of observations in a population. That is, a population which have how many observations are there in the population. So, population size can be defined as the number of observations in the population. The number of observations in the population is called population size. Or size of population, and is denoted by capital N. Based on this, we are having two types of population. Based on this, we are having two types of population. There are two types of populations. Which are finite population, second one is infinite population. First of all, how to explain about finite population. What is a finite population? The name itself, finite population, is nothing but if the number of observations in the population is finite, then it is said to be a finite population. So, finite population can be defined as finite population can be defined as if the number of observations in the population are countable or finite, then it is called a finite population. For example, when you tossing a coin, we get either head or tail. That means the number of observations are 2. In the same way, when you throw a die, we are having a numbers 1, 2, 3, 4, 5 and 6 on the die. So, I will give you an example for this. In a single throw of a die, we get the sample space as 1, 2, 3, 4, 5 and 6. Of course, these sample space elements are numerals, moreover which are countable. That is, the finite number of elements are there, 1, 2, 3, 4, 5 and 6. In the same way, we can take one more example. When you toss a 2 coins at a time, when tossing 2 coins at a time, we get sample space as head head, head tail, tail head, tail tail, or the number of observations are 4, which is also countable, that is finite. So these are the examples for finite population. Now I am saying about infinite population. Infinite population. If the number of elements are not countable, or the number of observations are not finite, is known as an infinite population. If the number of observations are not finite, then it is called an infinite population. For example, set of all real numbers which can be represented by R, and these are nothing but 0 plus or minus 1 plus or minus 2 plus or minus 3 and so on. Whereas natural number sets, these are also 1, 2, 3 and so on. These are the examples of infinite population. If you want a live example, the number of water molecules in a sea, or the number of sand particles in a seashore, the number of water molecules in a sea which are uncountable, so those are said to be an infinite population. In the same way, the number of sand particles in a seashore, which is also an infinite population. So after completion of this types of population, I would like to go for what are the types of samples. First, I would like to explain about sample size. What is sample size? Of course, this can be represented with a small n. The number of objects, the number of observations in the sample of any population is called sample size. If the number of observations in a sample is called sample size, which is also known as size of sample and is denoted by small n. So the number of observations in any sample is called size of sample or sample size. And is denoted by small n. For example, in the above example, we are seeing the number of elements in a single toss of in a single throw of a die. See here, in a single throw of a die, we are getting the sample space elements are 1, 2, 3, 4, 5 and 6. I am taking any sample from that example. S1 is the set of even integers or even numbers of that problem. We have 2, 4, 6. Here number of elements is 3, and S2 is one more example for the same problem, that is 1, 3, 5 is the set of odd numbers, and S3. Of course, S1, S2, S3 are samples of the sample space S, which is called a population. 2, 3, 5 is the set of prime numbers for that problem. Okay, friends, up to now we discuss about what is a population, what is a sample, and what are the types of population. Now I would like to give what are the types of samples. If you observe that small n is the sample size, based on this we can be able to define the classification of samples. There are two types of samples. One is, there are two types of samples. which are large sample and small sample, which are large sample and small sample. Second one, small sample. Large sample and small sample can be defined by the based on sample size. First of all, I have to say what is a large sample. First of all, I would like to say what is a large sample. If the number of observations in any sample less than 30, that is small and less than 30, then it is said to be a large sample. If the number of elements in any sample is greater than 30 or equal to 30, that is n greater than or equal to 30 is called a large sample. If the number of observations greater than or equal to 30, then it is said to be a large sample. That is n greater than or equal to 30. Whereas small sample can be defined as n less than 30. That is, if the number of observations less than 30 in any sample, small sample, if the number of observations in any sample less than 30, that is n less than 30, then it is called a small sample. Friends, last but not least, I would like to explain about sampling. Okay, what is sampling? Sampling is the procedure, or sampling is said to be a process. Which type of process? The process of selecting a sample from any given population. So, sampling is the process of selection of sample from the population. This is known as sampling. The process of selection of any sample from the given population. This is the sampling. Friends, up to now we learn what are the fundamentals of fundamental sampling distribution. Based on this, we can done the sampling in two ways. Based on this, the sampling can be done in two ways. That is, there are two types of sampling which are sampling with repetition and sampling without repetition. Without repetition. Without repetition. Friends, up to now we learn about fundamental sampling distribution. In the next class, we have to solve some problems on sampling with repetition and sampling without repetition. Thank you for watching.